Good morning, good afternoon, good evening, fellow geometers. I'm glad to see you join me today for today's lesson. Today we're going to be talking about the real-life application of the trig functions here. If any of you are going to take physics someday, you're going to use lots of trig functions, and you're going to see lots of different applications of the trig functions. But we're going to do basic trig and basic applications so we can see how this is applied in the real world. Now, with that comes along the expectation that you're able to solve story problems. Now, I know some of you are like, oh, story problems, are you kidding me? They're always so hard. I'm telling you right now, these are not going to be hard story problems. You're going to break them down into simple parts, and you should be able to solve all the story problems with no problem. For those of you that will be taking the PARCC test this year, I have seen some story problems dealing with the angles of elevation and angle of depression. So make sure you're able to grasp this concept today. First thing I want to make sure you understand is how to identify what an angle of elevation is and what an angle of depression is. The first thing is you have to know that each angle comes from a horizontal line. So I've drawn that horizontal line on the page there. And so an angle of elevation will elevate from the horizontal line. It rises from that. That's an angle of elevation. An angle of depression will depress or go downward from a horizontal line. So the first thing you're going to do whenever you see the word angle of elevation or depression, you're going to draw a horizontal line. And then you're going to figure out which direction you're going to go from there. And if you can do that, you can get almost every story problem that I'm going to give you correct. All right, now, the first thing I want to do, just to make sure that we are on the same page, first of all, you can see the definition right here. It's on your page of both the angle of elevation and angle of depression. And you know, you've got a couple diagrams here that show you what those are. But I'd like to drop down to numbers 5 through 8, and I'd like you to go ahead and just pause your computer right now and see if you can identify which ones of those angles, 1, 2, 3, or 4, are going to be angles of elevation, and which ones are going to be angles of depression. So take a moment and pause your computer and see if you can do that for me. All right, now, number 1, angle 1, is going to be an angle of depression because it is going downward from the horizontal line. I always start from the horizontal line and work either down or up. So this is downward, and that's going to be an angle of depression. Angle 3 is also working downward from the horizontal line, so that also is going to be an angle of depression. Angle 2 is going to be rising from the horizontal line. That's an angle of elevation. It's elevating, it's rising. And angle 4 is rising from the horizontal line. So again, it's elevating, it's an angle of elevation. Okay? So again, 1 and 3 are depression, 2 and 4 are elevation. Now, can anyone tell me what the relationship is between angles 1 and 2 or angles 3 and 4? Think about that. I hope that you're thinking in your mind that those are both angles, alternate interior angles. 1 and 2 are, and 3 and 4. So as a result, these two angles are going to be congruent, and these two angles are going to be congruent. So keep that in mind as we look at that. Now, the next thing I want to do, because it's been a little while since we've covered trig functions, I want to make sure that we can do some of these basic problems right here. So as we look at numbers 9 and 11, I'd like you to write down your paper there, so, ka, and toa. Okay, again, we're just going to do 9 and 11. And what I'd like you to do is to identify the 3 sides of number 9 and determine which trig function we're going to use. If you can go ahead and solve it already, if you remember what we did before, go ahead and do that. If you can't, that's fine. You can continue watching the video. But see if you can do that. Pause the computer and see if you can figure out how to solve for x. All right, now, what I would have done, just to make sure, I would have identified the hypotenuse first, opposite the right angle. And you notice that we don't have the hypotenuse. It isn't really part of the problem. These sides are, that side is not. So I can get rid of these first two trig functions right there. You know you're going to be using the tangent function. If I label the opposite side, that's this side. The adjacent side is that side. And so I'm going to set up my trig function. The tangent of 25 is equal to the opposite over the adjacent. Okay? Now, if you remember when we went over this, we went ahead and set these into a proportion. So it's over 1, and you just cross multiply. Okay? And so one thing, make sure your computer is in the degree mode, not the radian mode, because that will give you a wrong answer there. But go ahead and figure out what that's going to be. Okay? Now, nearest tenths place, like the directions say, I have approximately 116.6. That would be feet. Okay? That's how tall what looks like a building, the height of that building is going to be. Okay? Now, for number 11, I'd like you to go ahead and try that one on your own. See if you can figure out the length of that arm on that crane right there. Okay. Now, I would have identified the sides that I'm given. I'm given the hypotenuse, and I'm given the opposite side, opposite of the angle right there. So in order to figure out the length of that arm, I'm going to go ahead and, well, if I look up here, opposite hypotenuse, this time I'm going to use the sine function. And so if I write this down, the sine of the angle is equal to the opposite over the hypotenuse. We can then set it into a proportion just like we did before and go ahead and solve for x. Now, make sure you work everything out because it's a little different than the last one. If I cross multiply and cross multiply there, we get that. And then you want to go ahead and divide through by the sine of 40 to get x by itself. All right, and so if we work that out, 30 divided by the sine of 40, you should get something like 46.7 feet. Okay, it's bigger than my leg in my right triangle, which is good because it's the hypotenuse, and that's the answer there. Okay. All right, now let's go to the back side of our worksheet and take a look at that. Okay, and I want to apologize first before we get going here. For some of you, I made the copy of this worksheet before I made the adjustments here. So we're actually going to work on number 9 together. And as I do this one, know that there's some information that I added later I didn't realize wasn't a part of the story problem. So the first thing I want to make a note of is the note that's up at the top of your paper there. It says, surveyors use 2 instruments, the transit, which is what I've always known it to be called, and the theodolite. They're this exact same thing, it's just a different name, to measure angles of elevation and depression. Now, these instruments, I'm sure you guys have seen, you know, ODOT workers on the highway, and they're looking through a tripod, this little thing at the top of a tripod. That's what a transit is. On both instruments, the surveyor sets the horizon line perpendicular to the direction of gravity. Using gravity to find the horizon line ensures accurate measures even on sloping surfaces. So again, we know gravity coming straight down, and so if I set the horizon line perpendicular to that, okay, perpendicular right there, that is key for figuring out the horizon line. So if I can be on a road that tails off down into the valley, or I can be on a road that is climbing, and I can still figure out the horizon line. So using this instrument, we're going to go out to Arches National Park in Utah. Now, if you've ever been out west, in Colorado, Utah, you know, Arizona, you got the Grand Canyon, which is down into the ground. Okay, those are arches into the ground. And then you've got out in Utah and Colorado, arches that actually come out of the ground. Okay, and we're going to measure the height of one of these arches. Surveyor levels a theodolite with the bottom of the arch. From there, she measures the angle of elevation to the top of the arch to be 48 degrees. So this is very important, this information right here, angle of elevation. So when I read that, the first thing I draw is an angle of elevation, okay? And I'm going to go ahead and label that 48 degrees. She then measures the distance from where she stands to a point directly under the arch to be 36 feet. So, here's the arch. It's the top of the arch. Come on, measure down. And this distance right here from where she's standing to the bottom of the arch is going to be 36 feet. The theodolite stands 5 feet off the ground. Determine the height of the arch. Now, this is actually going to play into our final answer, but it's not important for right now. We want to determine the height of the arch. In order to do that, I'm going to go ahead and put X right there. Now, I think that you guys have enough information. You should be able to choose your correct trig function and be able to solve for X. So when I go ahead and grade your notes, when I look over your notes to say, hey, they did the notes accurately, I better see an answer for X. Now, I did say that this last little piece of information, this 5 feet, is going to play into your final answer, and here's why. Well, that transit that we were talking about, that tripod that they look through, if that is 5 feet tall off the ground, and we want to calculate the total height of this arch, you're going to want to include that 5 feet right there. So you're going to find out what X is going to be using your trig function, and you're going to add in 5 feet down here to get your total height of the figure, of the arch. Okay? So keep that in mind. Go ahead and do that for me, and again, I'll be checking that tomorrow at the beginning of class. Looking at the next one, let's see here. Don't think we need to do that one. Let's look at number 12. Okay, we'll just do this one as the last one. All of these story problems deal with angles of elevation and angles of depression. And so as you look at number 12, it says an airplane pilot sights a life raft at a 26-degree angle of depression. Okay. How many of you saw Unbroken early this year? Okay, great film. If you haven't got a chance to see it, if you have a weak stomach, you might not want to see it, but great film. And there's a scene in there when the Japanese fighter pilot spies the life raft floating in the water, and instead of trying to rescue the guys, they try to kill them by shooting them down. So, anyways, angle of depression. So the first thing I'm going to do, go ahead and show your angle of depression. This is my angle of depression right here. I start with my horizontal line, draw the line downward, 26 degrees. Okay. The airplane's altitude is 3 kilometers. So if this is my airplane right here, okay, don't make fun of my airplane. All right, here's my life raft down here. Okay, the height or the altitude is 3 kilometers. I'm going to put that right there. Okay, that's how high off the surface of the water the airplane is. What's the airplane's surface distance, D, from the raft? Now, you can really ignore D. I can use D, I can use X. It doesn't matter what variable I use there. But the surface distance. Now, that's where it gets a little tricky. What is the surface distance? Is this the surface distance, or is this length the surface distance? Okay? Well, the surface distance would be along the water or along the ground. That's where the surface would be. Okay? And so as a result, I would hope that you were labeling that as D, and now you can go ahead and solve for that surface distance. Okay? If I wanted to know the hypotenuse length of that triangle, I would probably say something like this. What is the distance the airplane is from the life raft? Okay? That's when I would identify this as the length that I'm trying to find. Okay? All right, so again, go ahead and do that problem for me. Figure out what that length of D is going to be. And make sure you show that to me for your notes, your credit. All right, thank you very much for your time. I hope that was understandable. We'll talk more tomorrow about the angle of elevation and angle of depression. But that was it. Have a good night.